Okay, so to get you ready for this chapter 6, at least most of the chapter 6 we'll be covering on this next test. I wanted to help you with this review sheet, so let's jump right in. So these first two problems are all about writing exponential functions. And so just like we've talked about in class a few times, an exponential function in general is going to look like this. Y equals this number that we call A, represents the initial value of a particular object. What did the object count or value start at? B represents either a growth factor or a decay factor, depending on obviously whether this original number is going up or down exponentially. And then X typically represents an amount of time that has passed over the period where the object or the item, could be population, how much time has passed since the growth or decay first began. So you can start both of these problems with this, and let's just fill in what we need for these letters. This car cost $50,000 when it was first purchased, so that's going to be our initial value. The B is in this case, it's going to be a decay factor because we're told that the car depreciates, and that's just another way of explaining that the car is losing value with each passing year, and it's losing value at 8%. So the way I do a decay factor is I start with the number 1, and then I subtract how much the decay is in terms of percentage per year, and in decimal form that's 8%. So B is going to be 1 minus 0.08, which is 0.92. And then this would be the function that represents the car depreciating at 8% per year. And now to use it to answer, well, what is the value of this car after 5 years? I just let X become 5. So I'll go ahead and do that. 0.92 raised to the 5th power. And so you can go to your calculator and type this in. I'm going to do the same thing, 50,000. And then we have 0.92 being raised to the 5th power. And after 5 years of this decline, depreciation, and we're told in this to round to the nearest dollar, this car is valued at $32,954. All right, so now let's jump to number 2. This is an increase in value, exponential growth. Well, it starts the same way. Everything's the same except for how we come up with the growth factor. So this property started off being valued at $10,000 when it was first purchased. But over time, it's increasing at 5.5%. So this time we're going to start with 1, and we're going to add, since it's growth, we're going to add 5.5%. So just write that as a decimal, 0.055. Add those together, and that is the B value, the growth factor, raised to the X, which represents a time period. In this case, again, it's going to be years. So here we go, coming up with the answer to the value after 5 years. So we're going to raise 1.055 to the 5th power, and go back to your calculator, and 10,000 parentheses 1.055, close parentheses, and raise that to the 5th power for 5 years. And this property has grown in value from its original $10,000 value to $13,069.60. So since we're told to round to the nearest dollar, I'm going to say 13,070. And that's my answer for number 2. So on your test, they may not be in this particular order. Just look for The word for declining in value or depreciation is another way of describing that. This is how you get the decay factor. Increasing in value, this is how you get the growth factor. Okay, then we move to problems like numbers 3 and 4, where we're solving, these are called exponential equations. And to solve these, we have to change this equation by rewriting these bases. The goal is to rewrite this so that the bases match. Well, right now, the base on the left side is 4, the base on the right side is 16. Obviously, they're not the same. So let's figure out a way to write 4 and 16 using the same base. And the base that we could use is 4. You could also use 2, but I'm just going to go with 4 because I know that obviously 4 raised to the first is still 4. So really didn't have to do anything to the left side, but I need to change 16 into a number raised to a power, and that number has to be 4, and 4 to the second is 16. So you're just rewriting what's given using bases raised to powers. And I just brought down the x. So when you get to this point where the bases match, now you can just take this left exponent, 3x minus 1, and let it equal the right exponent. Now remember, you got to multiply. When a power gets raised to a power, 2 being raised to the x power, you multiply those together. So that's just going to be 2x. And now you just go through your normal routine to solve for x. So if I subtract 2x from both sides, I'll just show that. That gives me x minus 1 equals 0. 2x minus itself. And then I've just got one more move, and that would be to add 1 to both sides. And so my final answer here is x equals 1. Okay, over here on number 4, the same thing has to happen. I've got to write 1/9, and I've got to write 243 using the same base number. So if I raise 3 to the negative 2, that's 1/9. And I need to raise 3 to something to equal 343. Remember, this is called the common base or the same base technique. And I believe if we take 3 to the 5th power, we get 343. So it still equals 243, but now it's written in a different form. So another reminder about this common base technique is, remember when we mentioned this in your notes, we said that this base, when you pick a base, it has to be greater than 1. Okay? Now, the bases that you're going to have to choose from typically are the numbers 2, 3, 4, 5, maybe 6. There's really not that many. I'm not going to give you huge numbers that you're going to have to use like 12 or 13 as a base. Typically, these problems are going to mean you're going to pick from about 6 different numbers, 2, 3, 4, 5, 6, maybe 7, maybe, but really not that many options. So we've rewritten the problem. It still equals the same. It's just in different form. So now that you've gotten to this same base, 3 on each side, now you're just going to let the left exponent, negative 2, equal the right exponent. So be careful here because these two exponents have to be multiplied together. Here's the exponent rule. When an exponent inside gets raised to another exponent outside, the rule says you multiply those exponents together. And so that's what we have to do. So this is going to be the distributive property here, 5 times 2x and also 5 times 1. All right, and now I solve for x. I'm going to subtract 5 from both sides. Negative 7 equals 10x. And then I'm going to divide by 10 on both sides. And I get my final answer is x is negative 7/10. Okay, so here's another word problem involving exponential functions. And let's see what this is talking about. So we're studying a bacteria population. The bacteria originally started, all right, keep that in mind, we started with 6,000 bacteria cells. So since we're asked to write an exponential function, remember we talked about this earlier, it looks like this. And A always stands for the initial value. So in this problem, that's going to be 6,000. So in just a minute, we're going to put 6,000 in place of A. Okay, after 2 hours, remember that's what X represents, an amount of time that has passed. So we'll put 2 in place of X. There were 28,000 bacteria cells. So in other words, 6,000 after so much time became 28,000. So Y will represent how much you ended with. Okay, so it's like A is how much you started with. You began with A, you ended after time and a growth rate, you ended with Y. Okay, so what we don't know, and when you see this problem on your test, you'll know what to do. You're going to have to figure out what B is. Okay, but you're going to know what to plug in for all the other three, and then you can solve for B. Okay, so let's just go ahead and plug those in. We ended with 28,000 after exponential growth. We started with 6,000. We don't know what the rate of growth was, so that's what B represents. We're going to solve for B. We do know that it took 2 hours to get from 6,000 to 28,000. So we got to solve for B. And when we find B, we'll be able to write this function specifically for this problem. All right, so to solve for B, I need to first divide by 6,000, undoing multiplication. All right, so we can go to our calculator and do 28,000 divided by 6,000. And that's a long decimal, 4.66667, or 6 repeating. And I'm not going to write that down. But what I'm going to do is just go ahead and tell you that since we're raising B to the second power, and maybe I will just go ahead and write it down, but you don't have to. I would just leave it sitting there in your calculator, and I'll show you why. But I want to show you basically what's about to happen. So we'll just show it like this for now. We know what B squared is. Okay, so just leave this long decimal in your calculator. And now we need to solve for B by raising B squared to the 1/2. So in this case, we just raise 2 to its reciprocal power. Well, I also have to do that to the other side. So with that big number, that decimal in your calculator, just hit this button called the caret on your calculator if it's scientific. And you're just going to put in parentheses, you're going to raise this 4.666 number, raise it to the parentheses 1/2 power. Now, it's very important that you use parentheses, because this is a way that we do radicals. But I think it's easier to find the square root of this number by raising it to the 1/2 rather than retyping it in using the radical feature. All right, so we found B, and let's just go ahead and round this. We're going to go 4 decimal places. 2.1602 is B. Okay, hopefully you got the same thing. So now we're ready to finish this letter A part off. We're going to write our function, and it looks like this. Y equals, we started with 6,000. The culture is growing at a rate of 2.1602. That's our growth factor. And we're going to denote that X represents really a number of hours in this problem. So there's my answer for letter A. Now we're going to use this function. Okay, so don't get too much of a hurry. I want you to show me the function that's generalized. Now use it for part B to show how many bacteria you have after 4 hours. Okay, so here's that same function, and this will this will be the way we get the answer for part B. All right, so in your calculator, you're going to raise 2.1602 to the fourth, because it's 4 hours. All right, back to your calculator, and this will be easy enough. Let the calculator do the work. Type in 6,000, parentheses, 2.1602, close parentheses, and raise that to the fourth power. And we'll just round this. Anytime you're dealing with living things like bacteria, just round it to the next whole. Okay, so you wouldn't, I know your calculator says 130,655.3. Well, we don't have a third of a bacteria, so just go to the next whole number. So in other words, round up. 130,656. And if you put 655, I wouldn't mark it wrong, but I do want you to do not give me decimals when you're talking about people or things. It just tells me that you're not really reading the problem very well and you don't understand the context. So that will be our final answer. You'll have a problem just like this, different scenario, different numbers, but this will be on your test. Okay, here's a compound interest problem, and anytime you see compound interest, you should automatically know that this is the formula that we use. Do you notice that I did not use that formula for any of these other problems that involve exponential functions? This is tailor-made, specifically designed for compound interest, compounded a certain number of times per year. So it's really just going to be used one time on your test, and you'll have one of these problems. Okay, so we're going to get the final amount of investment plus interest. We invested $8,000. That's P. 1 plus the rate of our investment. The interest is 4.5%, so make sure to change that to a decimal, 0.045. Compounding monthly, N is what that refers to, and monthly means N is 12. And then this N times T exponent, N again is 12, and T represents the number of years, which is 16. And so now just go to your calculator and type all this in, and I can talk you through that. So 8,000, left parentheses, 1 plus 0.045 divided by 12, close parentheses, and now you're going to raise, so hit your button, the caret button. Now if you're going to do 12 times 16 like this, you've got, just like I wrote, you've got to use parentheses around 12 times 16. Very important that you use parentheses anytime you have an operation, add, subtract, or multiply, or divide, in an exponent. You've got to put parentheses around the whole exponent. Okay, and for these, anytime for interest, we're just going to round to the nearest penny. So just keep in mind, when you do these compound interest problems, just round it to 2 decimal places. So our $8,000 investment became $16,413.35. And that's our answer for number 6. Number 7, use the appropriate formula, and that appropriate formula looks like this. We can find any term in a geometric sequence. Oh, this is the sum, so sorry about that. Wasn't reading this well. So let's back up. We're finding the sum of a series. All right, so here's the formula to find a sum. First term, 1 minus r to the n power over 1 minus r. Okay, n means how many terms? Well, we're told in number 7, 9 terms. That's no problem there. So we're going to find the sum of 9 terms using the first term, and we're also told what that is. 1 minus r. Well, we don't know what r is, but pretty easy to find it. If you just take these first 2 terms and take the second term, negative 12, and divide it by the one before it, then that'll show you what r is. And so in this case, r is negative 3. And negative 3 will be raised to the 9th power. All right, notice the 9 is inside the parentheses. Okay, and then the denominators can be 1 minus negative 3. Okay, so I noticed on the quiz the last time a few of you did this, and I don't want you to do what I'm doing now, but I just want to point out that this is an error that a few people made. Some people went ahead and just changed it to plus, but according to PEMDAS, we have a certain order that things are, we simplify in a certain order. Okay, so we always do powers or exponents in PEMDAS. We do exponents before we do multiplication. Okay, so that means we have to do this first, then this. If you just go ahead and change both of these to plus, then you've done the subtraction first before you did the power, and that's out of order. Okay, so just want to make sure, for those of you who did that on the last test and it caused you to miss this, if you just key this into your calculator, just like I have it, with one exception, we need to put all of this denominator in parentheses, then you've got it. You'll have it. So here's how it looks in your calculator. 4, left parentheses, 1 minus, I'm going to put negative 3 in parentheses, raised to the 9th power, close parentheses, divided by, left parentheses, 1 minus negative 3 goes in parentheses, and then we're going to close parentheses. So we have a little subset within a big set. Okay? And so if you type that in, and I'm going to do the same thing. All right, I'm typing that in using a different calculator than the one I normally use. Okay, so the sum of this series ends up being 19,684. That should be your answer for number 7. Now, what you could do instead of typing it in just like this, personally, I would just say divided by 4. But if you choose to let the calculator do all of this, just please make sure you put the entire denominator surrounded by parentheses. Okay, so number 8 is another problem like number 7, but it's presented in sigma notation. So we're going to use the same formula that we used before, but this time we got to pay attention to some things. Notice, unlike on the quiz where this bottom number started at 1, this time it starts at 2. So don't be tricked by this on your test. To get the number of terms, when you're looking at sigma notation, just take this top number, subtract the bottom number, and then do plus 1. We're doing plus 1 because we're actually including this bottom number as part of the list of numbers that we're adding up. So the number of terms that we're dealing with in this case is going to be 8. Okay, so I'm finding the sum of 8 terms. All right, so I need, according to our formula, I need the first term. How do I get the first term when I'm using summation or sigma notation? Well, again, we take this bottom number, n is 2, and we're going to literally change this n into 2. Okay, so it becomes 2 minus 1 exponent. All right, well, 2 minus 1 is 1, and then we do 2/3 to the first power. That's 2/3, and then we multiply that by negative 1. So the first term is going to be negative 2/3. All right, and then we do 1 minus r, and with summation or sigma notation, you can always see r because it'll be this base. Whatever is below the exponent n minus 1 or k minus 1, whatever is below, that's always going to be r. And so we're going to raise r to the 8th power. And then below we do 1 minus r again. And I'm just going to put that in parentheses. So we are ready. If we type all this in, I'll do this one in red. So if you pretty much type it in just like I have it using parentheses, you should be good to go. So let's see what this looks like. Maybe I think I would just go ahead and put parentheses around 2/3 just to be safe. I think that would be good. So here we go. -2 divided by 3. Close parentheses, and then I'm going to show that being multiplied. So I'll do another set of parentheses, 1 minus, and I'm going to put 2 divided by 3 in parentheses. And I'm going to raise that to the 8th power. All right, and now I'm going to close the parentheses for that whole group. Okay, so this, I'm now putting in this parenthesis right here on the right. All right, so I had a little subset within a big set. Okay, and then I'm going to do divided by, and then parentheses again, 1 minus parentheses 2 divided by 3. Close parentheses, and again, notice I've got two parentheses, total of 4. One here and then another one. All right, let's see what we got. Our answer here, and we'll do the same thing, rounding to, we'll just go 4 decimal places, -1.92, and it says 196, so we'll just say -1.9220. So just make sure, hopefully that makes sense. Go back and look at our notes and rewatch this if you have to, but understand how to get the particular information for this formula to find the sum, whether you're given a list, a series, or you're given the series in sigma notation. So make sure that that all makes sense. How to get the first term, R, how many terms, hopefully you understand that and practice it, because that's usually the problem that gives people a little bit of trouble. Okay, so now we do some, this is lesson 6.4, some log evaluation. And what I want you to do is, first of all, you will not be able to use a calculator for these, and I'll be watching, so make sure you're not using your calculator to evaluate logs. I do want you to show this step, just like we did on the notes and homework. I want you to take the log form and show me what it would be in exponential form. Okay, so some of you on the quiz did not do that, but this is what I'm looking for. I turned log base 3 of 81 into its exponential form. I just want you to see that when you evaluate a log, you're finding the required exponent to make this true. And so the log evaluation is 4. Log base 3 of 81 is 4 because that would be the power that I would plug in here to make this a true statement. 3 to the 4th is 81. Okay, show me again here. 15 raised to some power equals 1. That power is 0. 1/2 raised to some power is 1/8. That power is 3. 1/2 raised to some power is 256. So on these, I know some people have a little trouble, but the clue here is I'm taking a base fraction, and after raising it to something, it becomes whole. So that should be a clue to you that you're going to need a negative exponent to make this happen. Negative exponents cause us to flip bases over, and then once they're flipped, that's what the negative does, then we can just use whatever the power is. So what I would do if you're having trouble finding this in your calculator, just start raising 2 to various powers, okay? Like 2 to the 5th is 32, 2 to the 6th. So right now we're just hunting for the right exponent, pretending for a second that this is just regular 2. 2 to the 6th is 64. 2 to the 7th would be 64 times 2, that's 128. 2 to the 8th would be 128 times 2, which is 256. Okay, so if this were just regular 2, I know that this exponent would have to be 8. But since it's not 2, it's 1/2, the exponent's going to have to be a negative, which means it's going to be -8. Okay, so this would be the exponential form, and then the log, evaluating the log would mean that x would have to be -8. Okay, exponential form here, when I take 3 and raise it to some power, I get 243. So remember, we've already done 3 to the 4th up here, and we got 81. Well, 81 times 3 is 243, so that means it's just going to be one number higher. So it should be x is 5, 3 to the 5th power. And then when I take 16 and raise it to a power, I get a smaller number. I don't get a fraction, I get a smaller whole number. So this should be a clue that you're going to need a fraction exponent. These fractions are how we do radicals, square roots, cube roots, so forth. So it looks like what I've done here is I've written the square root of 16. So how do I show the square root of something in fraction form? I raise it to the 1/2 power. So in this case, the exponent would have to be 1/2. Okay, so be good. Hopefully you'll be good at changing log form to exponential and then evaluating from there. Tell me what the required exponent would be. All right, then we have some where I'm going to test your ability to know your log properties. And so, for example, when I solve this log equation, my number one goal is to make multiple logs. Notice I've got 2 logs on the left side. I've got to turn that into 1 log. And so I'm going to use the quotient property. 2 logs that are being subtracted become a single log using division. And now I've got single logs on either side of the equal sign, so I'm going to use the log property of equality. And if I got single logs on either side, it's like the logs cancel each other out. And I'm just going to solve this equation. I multiply by 2 on both sides, and I got x is 30. Okay, number 16, similar. I got 2 logs on this left side of the equation, and I got to convert that into 1 single log. And since they're being added, I'm going to use the product property. Product property says 2 logs being added become 1 log using multiplication. So distribute the n to both of these terms. Once again, I get to take advantage of the log property of equality. Since I have it in single log form and there's a single log on either side, so just mark out the logs, and you're going to solve this equation, which happens to be quadratic. So if you see a quadratic equation, you need to first make it equal to 0. So I'm going to subtract 5. And then solve by your favorite method, factoring, completing the square or quadratic formula. I notice that there are factors of -5 that add up to -4. That would be -5 and +1. And factoring makes it pretty easy to see what my solutions are, +5 and -1. However, I notice I've got an issue if I let n be -1 because it's not possible to do the log of a negative number. So I'm throwing -1 out as a possible solution, and I'm going to keep 5. So there's only one answer here, n equals 5. Okay, 17, another example of the quotient property. Take two logs and make them become 1. Two logs being subtracted become 1 using division. Now obviously I can't use the log property of equality here because there's no log on the right side. So I need to always think about, in cases like this, change from log form to exponential, just like we put in your notes. Always change log equation to exponential equation. So when I do that, I look at the base of the log. That's going to be the base for an exponent. What exponent? Well, logarithms are exponents, and so it's telling me that the exponent for this problem will be 1, and then I just let this fraction go on the right side. And now I solve. So notice when you go from log to exponential, you're not dealing with logarithms anymore. That's the beauty of this. Now we just solve this like a regular algebraic equation. So I'm going to multiply by the denominator on both sides. And that's going to make these cancel. And so I just have to make sure I multiply 4 by both of these. And I think I'll come over here. 4 times y, 4 times -2. And then on the right side, I'm just going to get 2y minus 2. And now you solve for y. Subtract 2y from both sides. And then add 8. And we got our answer of y equals 3. Quick check, and that does not cause the log of a negative or log of 0. So we are done. That's our answer for number 17. And then number 18, I don't have any logs to combine. I'm just going to go ahead and write this in exponential form. And there's no base showing, so that's understood to be 10. So I'm going to take 10 as a base, raise it to an exponent of 5, and that equals 2x plus 3. So 10, when you raise 10 to the 5th power, it's 100,000. And now you solve for x as you normally would. We'll subtract 3. And then divide by 2. And so x is going to be 49,998.5. Okay, so 19 through 22 are lesson 6-7 problems. And we've discussed how when we were dealing with log equations, we changed those to exponential forms. Well, these are exponential equations, and they need to be changed to log form. Well, it's just the reverse. Change exponential to log. So to solve these exponential equations, I'm going to do log on both sides. Okay, so that's my first move. I've taken an exponential equation and I've made it into a log equation. I did log on both sides. And the reason for that is now I can use the power property. I can take this exponent, because I'm trying to solve for m, and right now it's involved in an exponent. But the power property says if I have a log expression, I can bring this exponent down and I can use it to multiply. Okay, so I'm multiplying m plus 1 times log 7, trying to solve for m, So I'm going to undo this multiplication with division. So I'm going to divide by log 7 on both sides. That's going to cancel these. Leaves me with m plus 1, and now you just go to your calculator and hit the log button, log, and then type in 29, close the parentheses, right parentheses, and then divided by, hit the log button again, and put 7 in parentheses. And we've got the number 1.73044. That would go here, but I would just leave it in your calculator because to solve for m, you have to subtract 1 from that number. So just leave that number in your calculator and then do minus 1. And the final answer is going to be 0.73045. Let's see if our instructions tell us what to round to. 10,000th. It's 4 decimal places, so let's just make this 0.7305. Oh, 4, sorry, 7304. All right, so that's how those work. Number 20, similar. We're going to do log on both sides. So we can use the power property. So in this case, you've got r on both sides of the equation. So bring down r minus 1, bring down r using the power property. We need to get the r's together on the same side. So in this case, when r is on both sides, we're going to have to distribute. I'm just going to multiply log 12 times both of these. R times log 12, negative 1 times log 12, and now, again, it's important because we're trying to solve for r. Well, let's get r together, the r logs on one side. So I'm going to subtract r log 7, and I'm going to add log 12. I'm just going to switch places with those. Okay, and now you notice I've got a common denominator, or GCF, greatest common factor. So I'm going to factor out r. And to solve for r, I need to undo this multiplication. So getting kind of low down here. So we're going to undo multiplication with division. And now we're about ready to turn this over to your calculator. Okay, so in your calculator, this is what is going to get you your answer. So once again, you're going to hit the log button and type in 12, close the parentheses, and then divided by. Now you need to use parentheses around this whole thing, just like I'm showing here. So you're going to have these numbers inside parentheses, but the whole denominator needs to be in parentheses. All right, so log 12 minus log 7. And then the right parentheses really gets hit twice after 7. Okay? And let's see what we got there. 4.6102 is R, since we're rounding. 6102 is our final answer. Okay, and then we got some inequalities. They work pretty much the same, except for one difference that I'll highlight with you when we get near the end, but we're still doing log on both sides. And power property, this on both sides. distribute on the right side, just like we did before. Just think of log 5 being distributed to both of those. And we need to get logs that have x with them, like the two x logs need to be together on the same side, and if it doesn't have an x, then it needs to go on the other side. So I'm going to subtract x log 3, and I'm going to subtract 2 log 5. Okay, and now that you've got the x's together on the same side, I think I'll just come over here. We can factor out x, like we did on the previous problem. Just factor out the GCF. Log 5 minus log 3. Okay, so here you really have to be careful. We have that rule of inequalities that says if we multiply or divide by a negative, we have to reverse the inequality. It's not always easy to see, you just have to observe whether or not what we're going to be dividing by here is going to be a negative. Now in this particular case, since 5 is bigger than 3, log 5 is bigger than log 3. So when I subtract these, it's going to be positive. But let me just give you a for instance, so if this happens on your test, you'll be ready. If it were written like this, then this log, if you type that into your calculator, it's going to represent a negative number. And so you're going to be dividing by a negative number on both sides. And so you would have to switch this inequality. So this is a little bit tricky. It's not like you can actually see the negative number that you're dividing by. You know, a lot of times when we're dividing by, for example, -2, we see the negative and that's a reminder. In this case, you're going to have to observe, does this represent a positive or a negative? And it's all about in this case, if the number you're subtracting is bigger than the other number, then it's got to be a negative. Okay, so I'm going to put it back the way it was, but I just want you to be ready, have a heads up there. So the way it is, 5 is bigger than 3, so this will be a positive. I'm dividing by a positive number on both sides, so there is no need to switch the inequality. Okay, so let me show you what we'll be doing in your calculator. All right, so you're ready to go to your calculator, and you're basically going to type this in. And so x is going to be less than or equal to whatever this result is. So let's go to your calculator, and we're going to do -2 log, hit the log button, 5, close parentheses, all right, divided by, and now do left parentheses. Again, this is going to be one big set of parentheses around the whole denominator, and then we've got these two little sets around the numbers. So make sure you key it in like that. Log 5, close, minus log again, 3. And then hit the right parentheses twice after 3. And x is going to be less than or equal to -6.3013. And that's the answer for number 21. And now let me see if I can squeeze in number 22. Log on both sides again. Power property. And we just have the variable on one side, so these are a little bit easier to get to the answer. So to undo this multiplication right here, 2w minus 5 times log 6, I just divide by log 6 on both sides. So 2w minus 5 is going to be greater than, so let's go to our calculator and do log 23 divided by log 6, and that's going to give you a decimal. And I'm okay with you just leaving that. I need for you to show me how you got to this point. I would just leave that decimal in your calculator, 1.74995526, and then just go through your 2 steps that are needed to solve for W. Okay, so with that number in your calculator, you would say plus 5 equals, that takes care of this. You ended subtracting 5, and now you're going to do divided by 2 equals. And that should get you your final answer. W is going to be greater than 3.37. Looks like because of rounding, it's going to be 50. And those are your answers. Okay, 23 is another problem where we're going to test your ability to know the 3 properties. And so we need to take these. Now, we haven't talked about natural logarithms yet. Let's just change those to log. Natural logarithms have a different base, and that's going to be coming up in a future lesson, but the properties are all the same. So I'll have you change these to log when I give you the review sheet, or I'll probably just go ahead and change it for you. So you're just applying the properties just like we learned before. So the first thing that has to happen is these numbers 2, 3, and 5 have to be moved. They become exponents according to the power property. All right, so that's what I'm doing here. There's the power property, and then we could go ahead and just call these 6 squared is 36, 4 to the third is 64, and 1/3 to the 5th is, let's see, if you wanted to just do 3 to the 5th, will be the denominator. 3 to the 5th is 243, so that's going to be 1 over 243. And now, so we did the power property, and now we're just going to take these 2 at a time. These first 2 that are being added become 1 log using multiplication. So 1 single log of the product of 36 times 64, and that's 2,304. And 2 logs being subtracted become 1 log using division. Well, we never leave an answer like this. This is called a complex fraction. But we know that dividing by this is really the same thing as multiplying by its reciprocal. Okay, so let's go to our calculator and do 2,304 times 243. And our answer here is log 559872. All right, and so that's your answer for number 23. Okay, then we get to some review. Some of this is first semester review. So we have to solve this quadratic equation by factoring, and since there's a number in front of x squared, this is a good little review of the box method for factoring. I'll give you a problem like this on your test, just trying to help you remember this. So I'll put the first term and the last term, I multiply those together, and then I just search for the factors of negative 6x squared that add up to negative 5x. That would be negative 6x and positive 1x. So I fill in the other squares with those terms. And then I find the 4 GCFs from the 2 rows and the 2 columns. So going across the top, this would be 2x. And then across the bottom row, that would be 1. Going this way, the GCF of 2x squared and x would be x. And then going this way, the GCF would be negative 3. If both of the terms are negative, that makes the GCF negative. So the factored form of this given problem would look like this. 2x plus 1 comes from these, and then x minus 3 comes from these. And then I've got it in factored form, so now each factor separately, just take, if you have to, just take each factor separately and set it equal to 0. And so one of my answers will be negative 1/2. I'm looking for 2. One of them is negative 1/2, and then this one's pretty obvious, will be 3. All right, so far so good. Number 25. This is a problem to review the exponent rules. So the first thing I'm going to do is focus on the inside of this. I want to simplify everything in here first before I do anything with this. Okay, focus on the inside, work from the inside out. All right, so first of all, reducing 8/24. 8/24 is 1/3. Okay, and then now let's focus on matching x's. If I have x's like this that are being divided, I put those together as 1x and subtract their exponents. So it's like x to the 2 minus 3 power, which is x to the negative 1. And I know we're going to fix negative exponents, but for now, let's just simplify everything we can. And so the two y's would be y to the 3 minus 2 power, and that's just y to the first. And I've still got everything raised to the 4th. Okay. Now everything in the parentheses, not quite as much to have to look at now, everything that's being multiplied together, and then the 3 down on the bottom, everything gets raised to the 4th. 1 to the 4th is still 1. X to the negative 1 raised to the 4th is x to the negative 4. Y to the first is 4. 1 times 4. And then 3 to the 4th. 3 to the 4th is 81. Okay, so far so good. The only thing that needs to be fixed in this problem is I never want to leave an answer with a negative exponent. So the only term in this whole expression that needs to be changed is the one that I've circled. So x to the negative 4 on the top is going to be written as x to the positive 4 on the bottom. It's going to join 81. And that just leaves me with 1 times y to the 4th in the numerator. So there's your answer. So I'm going to give you a problem like this where you basically have to know several of your exponent rules. Okay, and then a review of transforming parent functions. Number 26 is the parent function y equals the square of the absolute value of x. And the parent obviously starts here, this rough sketch. It starts at the origin. So this would be the parent. And you don't have to draw the parent, but I just wanted you to remind you it starts here and has a slope of 1. Well, the red represents a shift of the parent 1 to the right and 4 down. So the way we show that is I show 1 to the right by doing minus 1 inside the absolute value, and then 4 down, I just do minus 4 outside. So there's your answer for number 26. 27 is a translation of the y equals x squared parent. And again, the parent would start here, and it's a terrible rough sketch, but it starts at the origin. Now this parent has obviously been flipped over. The red is a flipped over version of the black, and it's also been moved 2 to the left and 3 up. So to show all of that, I show the flip by putting a negative in front of the parentheses. And to show 2 to the left, I do plus 2 inside the parentheses, and then the 3 up, I show plus 3 outside. There's your answer for number 27. And finally, this is one of our newer parents. We covered this in Chapter 5. This is the square root. So know the difference between the square root and the cube root. Cube root goes in both directions. Square root just goes in one. So this is a shift of the parent, which would start right here and shoot off to the right. But this parent has been moved 1 to the right and 3 up. And so I show that translation. 1 to the right, x minus 1 would go under the radical, and 3 up, the plus 3 would go outside the radical. And there's my answer for 28. And we just have 2 more. Again, going back to Chapter 5, solving radical equations. Make sure you isolate the radical first. Isolate the radical first, so that means my first move here is to subtract 6 from both sides. And now I can undo the square root of by squaring. And that's going to make this become 4x plus 8 equals 9. I subtract 8 from both sides and then divide by 4 on both sides. It's always a good idea to check these when you have your test. If you have time, check them. Just plug this in for x. If you did, 4 times a fourth is 1. 1 plus 8 is 9. The square root of 9 is 3. And then 6 plus 3 does equal 9, so that one checks out. Okay, here I'm going to isolate the radical, but it's not really a radical that you can see. It represents a radical by using this 1/3 exponent. This is the same thing as the cube root of 5p minus 7. So to isolate the radical, I need to subtract 3 from both sides. And now, to undo the cube root, I raise to the 3rd power on both sides. So that's going to make these cancel out. I get 5p minus 7 equals 8. 5p is 15. So p is 3. And that's it. That's the material that I am going to hold you accountable for on the next test. So I hope this helps you in your preparation. If you have any questions between now and then, please let me know, and I will see you next time.